So, all right, that's fine. Now, let's have a think about what this can yield for us, okay? For example, let's come down to a point like here, okay? Now, I won't say anything yet about the angle. Tell me the coordinates of that point. That's going to be 1, 0. 1, 0, right? But we just defined those two numbers, 1 and 0, as the cosine and the sine of the angle related to this point, right? So 1 is the cos of an angle, and 0 is the sine of an angle, okay? The question is, what angle corresponds to this point, right? And the answer is, the angle is 0 degrees, right? Because I'm measuring from the x-axis and I'm on the x-axis, right? So that means that cos of 0 degrees is 1, and sine of 0 degrees is 0. Okay, I can keep going, right? You see, now I've got answers to these boundaries, right? Come up to the top. Come up to the top. What are the coordinates of this point? 0, 1. Right? Again, what's the angle that corresponds to that point on the circle? Answer, 90 degrees, right? So what this really tells you is that that's cos 90. Cos of 90 degrees is 0. And sine of 90 degrees is 1, okay? Can you see what's happening here? We are breaking out of the triangle, right? I can now work with angles that are 0. You can't draw a triangle with 0 degrees in it. And I can do triangles which have, you know, only acute angles, but I can do 90 now, right? All right, excellent, thank you. Okay, so I have some insights here, right? Let's keep going around and see what happens. I'm still up here, right? Let's draw an angle like, say, up here. Okay, now this time, right, because it's a point off in the middle of like wherever, okay, I don't know exactly what its values are equal to. So I'm going to go this time from the point of view of the angle. Okay, there you go. So remember, the angle, this theta that we're talking about, starts from the positive x-axis. I have to say positive because it's this side, not this side. That's the negative x-axis. There's the positive side. And then I go anti-clockwise, right? So this angle, another color, is going to be a reflex angle. Okay? Is that so far? Oh yeah, sorry, I'm obtuse. Wrong quadrant. Okay. So what angle should I choose? For the sake of my illustration here, I'm going to make that 120 degrees. 120 degrees. Now, I want to know what cos of 120 and sine of 120 are equal to. And inside this triangle, I'm kind of stuffed, right? But on the unit circle, I can work this out, right? Here's how I'm going to do it. Okay. I'm going to pop down another vertical line there and make a triangle. Make a triangle on this side, okay? And the great thing about this is if I have 120 degrees here, because the x-axis is a straight line, right? I can know what this angle inside the triangle is, right? It's 60. Okay. Now, if I know that that's 60, I also know what the length of the hypotenuse is. It's 1. Okay. So now I can work out what this side is, which will give me the cosine, and what this side is, which will give me the sine, right? So let's do this one first. Okay. What ratio do I choose? I choose cos. I choose it for two reasons. Number one, because it's adjacent on hypotenuse. But number two, because I'm now redefining cos is the x coordinate, right? So it's that far over, okay? So I can say this side here should be, well, cos of 60 will be this on 1, right? So cos of 60 is just that side. Cos of 60. Hold on. I know what cos of 60 is, don't I? It's cos of 60. Cos of 60 is sine 30, which is a half.
It's a half more.
Okay. In fact, you can see I've drawn my triangle pretty well, right? Because look, it's about halfway. Right? Because that's one over negative 1 of that.
You can't make it root 3 over 2 either because it's greater than 1.
Yeah, that's right. Okay, well, we'll get to that, okay? So I've got this side down here, cos of 60. Now I'll work out this side. Well, it's the other one, isn't it? So it's going to be sine 60, which is root 3 on 2. Okay, that's better. All right. So now what do I say? I want to know the coordinates of this thing. Okay? What's the x coordinate?
Minus half.
It's minus a half because I'm on the left-hand side of the Cartesian plane. Negative a half, right? And the y coordinate, well, it's above, so it's fine. That's root 3 on 2. Okay? So now, this is brilliant, right? This is not a ratio, minus a half. That doesn't make sense. Where in your triangle is your minus, right? And the answer is, well, 120, I'm outside that triangle now, okay? But I have a meaning for it because the unit circle gives me a meaning. Let's quickly go down to here. Let's come down to here. Now, if I'm not going to draw a triangle because my diagram's getting pretty busy, right? But if I were to pick out a point there, okay? Right away, you should be able to tell me the sign of the x-coordinate and the sign of the y-coordinate. They're both going to be negative, right? Because look, I'm negative x and I'm negative y. Does that make sense? Okay, now, let's take that idea. Let's take that idea because this is where one of the most common abbreviations comes from, right? I want to think about sine, cos, and tan in each of these quadrants. Sine, cos, and tan. Okay? Now, remember... Yeah, we'll get there.
That's why.
Okay, think about this with me. Remember, the cosine is the x value, right? So let's just do that for the whole diagram, okay? For cosine, right? Over this side of the diagram is cosine positive or negative? It's positive, isn't it? Because on this side, all the x's are positive, right? Whatever number you pick, the x will be positive. So cos will be positive here, and it will be positive here. Does that make sense? You cross over, all these values are negative, right? So cos is negative here, cos is negative. You can play the same game doing sine, except above the axis, sine is positive, 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 and below the axis, sine is negative. Okay, now tan we said was the ratio between sine and cos, right? So it's one divided by the other. So if I divide two positive numbers, what will the sign of the ratio be? Answer, positive. Okay, if I divide, it's sine on cos, isn't it? A positive number by a negative number, what will the sign be? Negative. If I divide two negative numbers, positive. And lastly, this is the same as over there, that'll be negative. Okay, now step back. Have a look at what we've determined. Over here in the first quadrant, it's the first quadrant because that's where you start counting. Okay? In the first quadrant, all three of our main trig ratios, or should I say trig functions, they're all A for all, positive. Okay? As I go around the unit circle to different quadrants, I only ever have one ratio that remains positive. Right? Over here, what's positive? S for sine. Down here, T for tan. And then over here, C for cos. So some of you have heard this as the acronym, starting from the first quadrant, A, S, T, C. Which, depending on who you ask, stands for all stations to central. Or if, or
All students talk about that.
add sugar to coffee. Or if you were, I don't know if anyone knows, at my old school, down the road there was a comprehensive school which didn't quite have as good an academic reputation as James Roos. So there was a teacher who was very fond of saying, all students to Cumberland, because that's where you go if you don't understand.
Oh my god, that's Mr. Lee.
If you're, no, in fact, Mr. Lee has another one, which is, I don't know what he says about his classes, but he says, all students take cocaine.
Oh.
So, yeah, okay, well, obviously, you know, you were junior students, so he gave you the PG version, but, you know.
Obviously, he thinks highly of us.
Yeah, obviously. So, okay, now, here's the thing though, okay. This acronym, I really dislike this acronym. I don't like it. The reason why is because, not obviously you guys, but many people learn it, ASTC, and it masks understanding what's really going on, right? All that's really going on is, look, my x and y's will be positive up here, because x is positive here and y is positive here. Look over here, x is negative, and y is positive. So that's why the corresponding trig functions will have the same signs. That's really what's going on. By all means, use all stations to central as a crutch, okay? To help you remember, to help you evaluate things, okay? But please, 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 know what's actually going on. It's just about x's and y's.
So it can be negative, like sine can be negative and cos can
Yeah.
be negative.
Sine, cosine of 120 degrees is negative a half. And if I come down to here, right, for instance, if I said sine of any angle between 180 degrees and 270 degrees, all the cosines and sines of all those angles will be negative. Okay?
Is that what your calculator would give you? Or
Yeah.
you just add it?
Yeah. Go ahead. You chuck in, with the one we worked out just now, was cos of 120, and it'll tell you minus a half.
Oh, cool.
Now, by the way, it's not that this thing is smart, it's just that this thing has been told to do this, right? So it gives you the right value. Okay?